Well, greetings everyone once again. I thought we'd start the class today by going over the homework I assigned last night. Hopefully you've already sent it to me so that you can get credit for it. So here we go. We're going to whip right through these problems quickly here and make sure that you have a good understanding of them. Okay? So it says determine which would be taller, a large piece of paper folded 23 times or a small mountain which has a height of 0.55 miles. Well, if we have 23 folds on a huge piece of paper, we better figure out how many pieces of paper that would be, right? And then maybe convert that over to like inches or even to feet, all right? And then we can convert 0.55 miles into feet, and we'll see which is bigger. Okay, so let's start with the folded paper. If it's folded 23 times, it's 2 to the 23rd power, right? Number of folds. All right, so I'm going to bring up my calculator over here, and I'm going to figure that out. So 2 caret 23, and you should be doing the same thing with me if you haven't done it already, all right, is 8,388,608 sheets of paper. All right, 2 caret 23, I'm just double checking my work, 8,388,608 sheets. Now, we should have started with that, right? Like so. That is sheets, all right? For each 250 sheets, we would have what? 1 inch. And why don't we just put it into feet, okay? So there are 12 inches in every 1 foot, okay? So if that's the case, all right, what do we got? Well, we did 2 to the 23rd power already. It's in the calculator. I'm going to divide that by 250, hit enter, and divide that by 12 and hit enter, and I get approximately 2,796.2 feet. Now, 0.55 miles. How many feet is that? Well, if we take 0.55 miles, you stick it over 1, there are 5,280 feet per every 1 mile. So if we multiply these out, well, actually we divide it, right? So we'll take on our calculator 0.55 miles. We will divide that by 5,280. And when we do, let's see here. Let me see here, 5,200. Okay, I think I did that upside down, didn't I? You guys should be slapping me right now, right? So let's flip that back over the way it should be, right? So let's take this, erase that, and we want to put the 1 mile down here, right? 5,280. The advantage of having taught a while is that you can look at your answer and you can tell whether or not it makes sense. I got 0.00001 feet, and I knew that was crazy. So, all right, so what are we going to do? We're going to take 5,280, all right, and we're going to multiply it by 0.55, and when we do, we get 2,904 feet. So look at the comparison of those two, 2,904 compared to 2,796. So the small mountain, all right, has a taller height, okay? We've put it both in the same unit of measure so we can tell that the mountain is the winner. Now, let me make sure that I did that right. So I'll look over here, and there's the problem worked out, okay? And I have the 2904 right there, as you can see, and the 2796. So we know we did it right. Okay, let's go back. All right, convert 4 years into seconds. That's a pretty simple, quick fix. So let's do that. Let's take 4 years. There are, what do we go to next? Days, right? There are 365 days in 1 year. We have to take the days and convert them into hours. There are 24 hours in every single day. All right. So days is canceled here. Years is canceled. I'm now in hours. Let's get to minutes. Remember, I put the 60 on top because that's where minutes has to go. So it will correctly cancel with 1 hour. All right, hours have canceled. And finally, I will go to 60 seconds in 1 minute. All right, so if I multiply all those together, I will obtain my answer, right? So I do 4 times 365 times 24 times 60 times 60. And when I do, I obtain one big mama number. 1, 2, 6, 1, 4, 4, 0, 0, 0. Putting in the commas, it's 126,144,000 seconds. Let's see how we did. 126,144 seconds. We did all right. Okay, now I'm not going to, on the final exam or your next test, ask you to determine whether a number is prime or composite. So I'm just going to kind of quickly go through this question with you. All right, I have the answer key here for you to look at. Remember, we have to take the square root of 1517 to see where to stop testing. If you recall, right, the square root of the number in question is where the factor shift should occur. Where the factor shift occurs is where we can stop testing. So we divide all the primes we can up to the number roughly 38. Now you can see I did it for all of those numbers, but you notice when I got to 37 down here, it went in. The very last number that could go in did go into it evenly, and we got 41 for the other factor. So the prime factorization of 1517 is 37 times 41, okay? All I will ask you to do when you finally do take the final exam is to get the prime factorization of a number. I won't make you go through all this. All right, let's go back. Okay, so we kind of skipped that, but we've gone over it kind of. Let's take a look at 24. A paper bag contains 15 M&Ms. 7 are green, 3 are red, 5 are blue. If you reach into the bag, here is the symbols showing the colors. Okay, how many must you draw out to make absolutely certain you have drawn out for A, 2 M&Ms of the same color? Well, is it possible you could draw a green one first, a red one second, and a blue one third? Yeah, you've already drawn 3 M&Ms out of the bag, or picked 3 M&Ms out of the bag, but you have not gotten any M&Ms that are of the same color. So to get 2 M&Ms of the same color, what, however, has to happen on the very next draw. Well, if you have the 3 colors already covered, right, one of each, you're going to get, right, another M&M that's one of those colors. So you would have to draw how many? You would have to draw out 4, right? How about 2 green M&Ms? Is it possible, probably would never happen, but is it possible that I could draw out all the red M&Ms and all the blue M&Ms first before I ever even got a green one? Yeah, it is possible, right? So that would be 8 M&Ms I would have drawn out of the bag or picked out of the bag and never gotten a green one. So how many more would I have to draw then to guarantee that I had, all right, 2 green M&Ms? It would be what? A total of 10. If you take out 10 M&Ms out of that bag, pick them out one by one, you're guaranteed you're going to have 2 green ones, all right? Certainly, you would probably get 2 green ones prior to that, but to absolutely guarantee it will happen, you would have to draw out 10. 2 M&Ms that aren't green. Now, they could either be red or they could be blue. We don't care. They just can't be green. Well, what if you drew out all 7 M&Ms that are green first? If you did that, right, you haven't gotten any other colors that are not green, right? So had you been able to do that, which it probably would never happen, you'd have to draw 2 more. We don't care if they're both red. We don't care if they're both blue. But the point is, a total of 9 marbles would satisfy that situation. And how about 2 red ones? Okay. Is it possible that I could draw out all the green ones and blue ones first before ever getting a red one? Yes, it is. So if that happened, I would have drawn out, sorry about the clocks, we would have drawn out 12 marbles already, or excuse me, M&Ms already, which are not red. So we need 2 more to guarantee they'd be red. So that would be 14. So let's see how we did. My answer key is right here. Okay, I'll pull this down a little bit here. 4 was the first one, 10 was the second, 9 and 14. And I believe that's what we had. So it looks like we did all right. All right, let's take a look. Yep, 4, 10, 9, and 14. Okay, look at 25 with me. Jones Nursery School enrolls 2, 3, and 4-year-olds. They have to be 2, and they can be no older than 4. Okay? If their Tuesday, Thursday class is made up of 39 students, explain why we are guaranteed that in that class at least 2 children must share the same birth date, both month and year. Saying birth year and month now, not day. Birth year and month. Well, there's 39 students, right? How many months over those 3 years could they be born in? 36, right? So there are more students than there are months to be born in, right? Therefore, what? Duplication must occur. Must occur. All right. PHP, baby. PHP. QED, you've done enough. Okay? You know I'm going to ask that on the final exam. Something like that, right? You know it. Okay? There's no doubt about it. Whoop. Okay, let's go here. How do we make out here? Yep, duplication must occur. 36 birth months over 3 years. So there's the birth months over 3 years PHP because of the fact there are more students. I didn't say that there, but there are more students available than there are months for them to be born in over those 3 years. Therefore, we know by PHP it's duplication, and it has to happen. It has to be a duplication. Okay, let's go down to the next one real quick. Whoops, sorry, I keep going in the wrong way here. Come on, baby. All right, here we go. All right. Using this chart, let's write 405 as the sum of several non-consecutive Fibonacci numbers. So if I write down 405, I notice that the closest Fibonacci number to 405 is 377. How much did I miss 405 by? All right. How much did I miss 405 by? 405 minus 377 gives me 28. If 28 is a Fibonacci number, I'm finished. Unfortunately, it's not, correct? So 377 plus, what's the closest Fibonacci to 28? I believe it's 21, right? And when I subtract 21 from 28, I get 7, right? 7 is not a Fibonacci number, so I have to keep going. The closest fib to 7 is 5. Whoop, I should put a 5 here, sorry. And what do I have to add to that? How much have I missed 7 by? By 2. 2 is a Fibonacci number. So here's our correct answer. 377 plus 21 plus 5 plus 2. And one final question on the back of group work 25 that I asked you to try was to evaluate this expression using the Fibonacci and Lucca tables to get what you need here. All right, it's going to be 3 times, now what Lucca number is this going to be? Well, I put 11 in for n. 2 times 11 is 22. I subtract 6, I get 16. So this will be Fibonacci number 16. The second part, I put the 11 in for n. 11 plus 3 is 14. So I'm looking for Fibonacci number 14, which I will square. What do I come up with for an answer? Well, I'm sorry, I did this wrong. This should be a Lucca number here. Sorry, let me change that real quick. This should be a Lucca number here, not a Fibonacci. Lucca 16, right? I didn't go and look any numbers up on the table yet, so I'm still okay. All right, so what is Lucca number 16? It looks like 1364, and I will triple that, right? And I will add to that the square of Fibonacci number 14, which is 377 squared. Well, first I'll do 1364 times 3. And when I do, I get 4092. To that, I'm going to add the square of 377. When I square 377, I get 142,129. So I add that to 4092. And when I do, I get 146,221. So let's see how we did. Okay, let's see how we did. All right, here are the last 2 answers on the sheet. Looks like we did all right over here, and it looks like we did all right over here. So there's a quick review of material that will show up on the final exam, but it probably will not be on the next test, okay? And the next test I'm hoping to give you during the day on Friday to complete, all right? And when we get into Actually, I might even give it to you Thursday night. We'll see. All right. But we'll touch base with all that as time goes along here. Okay. All right. So now it's time to go to Group Week Worksheet 26, the back. All right. And we are now going to determine the missing value in this bank routing number. And if you recall, the bank routing number, the number that you multiply to check this out is 739, 739, 739. I get 0, 6, 18, 0, 0, 0, 7x, 9, and 81. Well, this is an 8, and this is a 1. So now I add all these digits together and put them with the 7x. So let's see. 9 and 1 is 10, and 8 is 18, and 6 it looks like is 24. Adding the other way, 14 and 9 is 23, and 1 is 24. This has to come out 0 mod 10. What must 7x end in so that when I add it to 24, it ends with a 0? Well, I think you can see it has to end in a 6, right? X has to be a one-digit number, right? So what do I need? I need x equals 8, don't I? Because 8 times 7 is 56, and 56 plus 24 does give me 80, which is 0 mod 10. So x has to be 8. All right, let's go on. Determine the missing number in this bank routing number. 739, 739, 739. All right, 14, 4, 18. Notice this is a much harder bank routing number because the digits are all there. There aren't any zeros in there. All right, 21, 9. Oh, there's a 0 there. All right, 15 and 36. So this is 4, 8, 1, a 5, and a 6. So I'm going to need 7x, right? Plus, now I'm going to add these both ways to make sure I don't screw up. 1, 4 is 8, 8 is 16, 17, 26, 31, 37 that way. I'll add back the other way. 6 and 5 is 11, and 9 is 20, 21, 29, 33, 37. Again, I got 37, so we should be all right. ST equals 0 mod 10. What does 7x have to end in? So when I add it to 37, I get 0 mod 10. Well, I believe you can see it has to end in a 3, right? What number does x have to be so that 7x ends in a 3? I believe you can see it has to be 9 because 7 times 9 is 63, which added to 37 is 100, which is 0 mod 10. Okay, let's go on. I know I'm doing these kind of fast, but I think you are probably pretty good at this by now. And if you tried this last night, you're going to be able to find the mistakes you made quickly here by looking at what I'm showing you. We only have 4 more to do, so let's whip right through them. How about this bank routing number? Okay, 739, 739, 739. 14, 6, 9, 21, 24, 9x, 7, 6, 63, which is just 3, 24 is 4, 21 is 1, and 14 is 4. All right, adding left to right, I get 20, 29, 30, 34, 41, 47, it looks like 50. All right, let me add the other way. Going back, 3 and 6 is 9, and 7 is 16, and 4 is 20, 21, 30, and another 10. Ooh, it's only 40, right? Did I mess that up? 9 and 6 are 15, 19, 20, 30. Oh, it's only 40, right? It's only 40. All right, let me add again. 10, 10. I'm going left to right. That's 20. And 13 is 30. Let's see. 6 and 4 is 10. And another 10 is 20. 24, 31, and 9 is 40. Yes, it is 40. Okay, now, what's 9x have to end in? Got to end in a 0, doesn't it? Right? To add to 40 to make it end in a 0. So x must be what? 0 here. All right, let's try a UPC code. All right, let me look that up to the top a little more. 313131. Remember, on the test I will give you for the final and this week, the 313131 will be on the test. So will the 739, 739, 739 you need in case you happen to forget them. All right, so 15, 7, 6, 0, 0, 0. Oh, this is a nice one. 0, x, 3, and this is 28. No, that's a 28. That's not a 7. That's a 1. So this is a 4. All right, I think I did that all right. 15 is the only 2-digit number. Adding across, I have 12 from left to right. 12, 19, 25, 28, I believe 32. Notice it's only an x. Makes this pretty easy. 4 and 3 is 7, adding backwards. 4 and 3 is 7. 6 is 13, 20, 25, and 7 is 32. What number does x have to be in order that the 32 ends in a 0 when you add it to it? X is going to have to be what? Obviously 8. Okay, 2 more to do, and we've got this sheet all taken care of. All right, the UPC code here for, these are probably, what is it? Are these peanut butter cups or something here? I don't, doesn't make any difference. Let's just do it. 3, 1, 3, 1, that's a 1. 3, 1, 3, 1, 3, 1, 3, 1. All right, 0, 1, 6, 0, 0, 0, 21, which is 1, 1, 6, 9, 3x, and 9. Okay, 21, of course, was 1. I already changed that. Adding across, I get, of course, I'm going to have 3x plus 1 and 6 is 7, and 1 is 8, 9, 15, 24, 33. Let's see if I get the same thing adding the other way backwards. 9, 18, 24, 25, 26, 32, and 1 is 33. All right, what does 3x have to end in order to be added to 33 to become a 0 on the end? All right, you know 3x has to end in a 7, and you know that the only way that's going to happen is if x is equal to 9. All right, one last question to try. Okay, all right, so here we go. So this is bank routing number again, 739, 739, 739. Okay, and 0, 6, 18 or 8, 7x, 3, 0, 7, 6, and 9. Okay, adding across, I will have what from left to right? 6 and 8 are 14, 17, 24, 30, 39. Let's see if I get 39 adding the other way. 9 and 6 is 15, and 7 is 22, 25, 33, and 6 is 39. So it looks okay. All right. 7x has to end in a what? Has to end in a 1. Okay, so what does x have to be then? X has to be 3, right? Because 7 times 3 gives us 21, and it added to 39 gives us a total of 60. Okay, so we've gone over quickly the homework that you were assigned, all right? So you can rest assured that you did that okay by the fact that we've gone over it. Now, what I'm going to ask you to do next is to watch 4 different videos involving types of numbers. A couple of the videos are kind of a cartoon type video, but they do a great job. That's why I picked them. And the first 2 videos are done by a couple of teachers, okay? So I want you to look at these carefully, and after you have looked at these 4 videos, I will come back and go over some of the stuff that you have seen. So enjoy the videos. You might want to take notes as you go, but pay very close attention to what these folks say, and you should be in great shape, okay? So with no further ado, we are going to stop recording here, and I'll see you shortly.